All right, hello once again. This is Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College Application and Website Development, or AWD1100 Programming Fundamentals with C# course, I've been creating a series of videos that are based off of the PowerPoint slides for the textbook we're using for the class, that being the book you see right here, Muroc C# 7th edition. So far, I have done everything in Section 1, everything in Section 2. From Section 3, I've made the personal decision I'm not going to do 13 or 15, but I have done 12 and I have done 16, so I'm going to come back now and do Chapter 14, How to Work with Inheritance. Now, I am broadcasting from my home, so at any time my dog might start barking, the grandfather clock may make noise, something, the doorbell might ring, etc. So if that happens, I just am apologizing in advance, and I'm going to get to it by getting into Chapter 14, How to Work with Inheritance. At the end of this chapter, where are we? At the end, we will, come on, there we go, add memory functionality to our calculator. Okay, by adding a memory class, and I'll wait on that until we get to that point. So, how to work with inheritance. As always, this is our cover slide. Our applied, we only have one applied objective, basically be able to use inheritance correctly in an object-oriented program rather. Then for the knowledge, explain how inheritance is used, explain why you might want to override several methods, such as the one shown there. Describe the use of protected and virtual class modifiers or access modifiers. Describe the use of polymorphism. Describe the use of the type class. Describe explicit casting, and distinguish between abstract classes and sealed classes. So, believe it or not, you've been using inheritance all semester. Now, inheritance in many ways, is like genetic inheritance. And what I mean is, typically, you get man A with big nose who marries woman A with big nose, and they have a child, then typically the child has a big nose. Now, does it always work like that? Of course not. But quite often, it does. And so what happens if the child has a big nose? Well, you all know this already, but the child can live with a big nose. The child can get a nose job. And really, when you think about it, that's probably about the only two options. It's not like the child can take off the nose that she or he was born with and put on another one. But in essence, that's what you can do when you are working with inheritance in programming. All right? So the base class, what they call the base class here, is the parent class. What they call the derived class here is the child class. So if I create a child from the parent, notice that the child automatically gets these three different properties, these three different methods, or four, whatever, I guess it's three, and then can go and add anything to that they care to add. Be it more properties, be it more methods, or both. What they're saying here is for your form control classes, the way that this is set up, all the classes that we've been using basically all semester with things like buttons, checkboxes, radio buttons, etc., they're all part of a hierarchy, and they're all part of an inheritance hierarchy. Now, what you get out of the box when you go in and you create your C# programs is you get the system.object class. So in other words, virtually everything, that's the root, that's the top, that's the parent, grandparent, great-grandparent, great-great-grandparent, etc. of everything. So you automatically get out of the box these 8 different methods. I'm not going to read them to you, but you can see them right here. All right? So what they're saying here is with the application that we've been working with thus far, it's been a product application. And really what we've been doing so far is we've only had one type of product. And what I mean is they've all been books. So all of the products that we've been using have been books. But imagine that rather than just books, you had books and you had software. So book and software are children or derived classes of product. So as you notice, they automatically get code, description, price, and have those three properties, and the method get display text, code, description, price, and the method get display text. In addition, the book class adds a string property called author. The software class has a string property called version. All right. And the stuff that's here, this is going to be our list of products that we're going to have. Okay. So if you look in here, it says the code for a simplified version of the product class. So what they're saying is basically any product that you create will have these three different properties: a string for the code, a string for the description, and a decimal for the price. And it will have one method, a get display text. So that's all products get this. But then we come in, and just to show you, all right, what we're going to say is a book colon product, which means a book is a child from product, or book is derived from product. All right. So again, as we look at this, these are the access modifiers that we can work with. So some of these we've seen before. I will tell you, in my humble opinion, if you understand public, if you understand private, and if you understand protected. So on this list of 6, if you understand 1, 2, and 6, you'll probably very rarely, unless you are a professional C# developer doing very intricate type of work, you probably will never have to work with internal, protected internal, or private protected classes. I never have in all my years as a C# programmer. But public means that everything, it's kind of like a public figure. Now, I realize this is not how it works, but technically, as a public figure, what I should be able to do is I should be able to drive myself or take a plane to Washington, go to the White House, knock on the door and say, hey, I'm a voter. I voted for you, President Biden. I'd like to meet with you. Now, I realize that's not how it works for security and a lot of other reasons, but a public figure means that technically that figure is available to the public. In much the same way, a public class or a public method or a public variable is available not only to the class in which it's been created, but to all other classes as well. And again, remember, it's very rare that you will ever have a public variable. Rather, most of your variables will be private, meaning they're only available to the current class and they can only be manipulated using the public methods of that class. Now, you can have private methods. We looked at those when we went through our example of the calculator, and they're typically referred to as helper methods. All right. The other one in here that I want to talk about is protected. If I declare something in a parent class as being protected, and then I create a child or derived class based off of that, that means that not only can the parent change it, but the child can change it as well. All right. So they give some stuff in here that you can use. I'm not going to run through this right now. All right. This is, again, is that code, and I started showing you this before for the book class. And, well, somewhere in here will be the code also. Maybe they don't show it. I thought they did for the software class. So what do we have here? Public class book is derived from product, or public class book is a child of product. Now, if you were doing this in a different language, such as Java, you'd say public class book extends product. But here we use the colon. You will use the colon both for a child class, and as you'll see a little bit later, that you also use the colon for the interface. All right, so what's new here? Well, the author. That's the new property. Everything else we can use directly because book is a type of product. So notice on here, when we create the constructor, code, description, author, and price. But notice the parent will handle the code, the description, and the price, and we in this book class will be responsible for handling the author. And again, we can still come in and override the get display that we got from the parent. Totally fine. You'll quite often do a bit of overriding in these things. So we've got it here, display text with a separator, and here we've got it. All right, so here we are here we are passing in a string for the separator, and I guess we are here too. So we've got get display text. Not sure exactly what they're doing right there. All right. It says a virtual get display text method in the product class as opposed to an overridden one. All right, we're going to get into this in much more depth and breadth of coverage as we get going. I don't want to go into this in too much detail right now in case somebody has the wherewithal that they are literally watching this stuff and they're watching it before the semester starts, because it's so easy to confuse you in here. So notice when we do the book B, there's the title. I'm sorry, there's the code, there's the title, there's the author, and there's the price. So again, the parent class of product will be responsible for the code, the title, and the price, and the book class will be responsible for the author. For the software, same kind of thing, except that the parent or product class will be responsible for the code, the title, and the price, and the software class will be responsible for the version. Okay? All right, so now what they have in here is they are able to add, when they add a product, they can add either a book or they can add software. All right? And if you click here to add product, you have to figure out which of these. So if I choose book here, notice these two look the same except this has author and this has version. The two forms look identical to one another. I believe they're two forms. This is the one that'll come up if the radio button for book is chosen. This is the one that will come up if the radio button for software is chosen. All right. So here's your code for the product class. And we've already talked about this. It looks familiar. All right. The code, the description, and the price are handled internally in this class. And notice there's our getters and our setters. They're just typical getters and setters. We make get display text virtual, and what that means is the get display text can be overridden by any class derived from this class, such as the book class. And here we're overriding it. If you want to be able to override one of the parent methods in C#, you must put the word virtual in there. So again, in here you've already seen this, but here is our book class, which is derived from product. And in this is our constructor that'll do basically set code. All right, it'll set code equal to, since it's a string, the empty string. Same with description, same with author, and price will be set to 0. In this one, we are saying that we want the base, which means we want the parent to handle the code, the description, and the price. So that'll call this. And we will handle the author. And there's our getter and setter for the author. And since we said this was virtual with a get display text, we can override it in here. All right. Here's our product, much the same way. So again, public class software, derived class software gets derived from or is a child of product. There's our constructor, our no-R constructor, where the code will be set. All right, the code will be set to the empty string, the description will be set to the empty string, the version will be set to the empty string, and the price will be set to 0. We're going to let the parent, which is product, handle code, description, and price. We will handle version, and again, because getDisplayText was created as virtual, we can now override it here. All right, now we've got a product list class. This is going to be the class that's going to list all of our products. All right, and you'll notice it inherits from list of products. Okay, so it says modify the behavior of the add method. Provide 2 fill methods. All right, so again, it says provide 2 additional fill methods. So here's fill, and this is the standard fill, all right, to basically go through everything that we currently have and use it, I believe, to fill up our list box. And here is we're maintaining, so you'll notice, I guess, this is where we're actually filling the list box, and we're using a for each. All right, and we're telling it that between each field we want a tab. All right, there's our add. Notice if product not equal to null, meaning we've got something written in there, we will add it, we will save it, and we will add it to the list box. So this is adding it to our list of products, saving that list of products, and then using it to fill up or add to the list box. When we delete, if I is equal to -1, we haven't chosen a product to delete. Otherwise, we say, are you sure you want to delete? We give them the description. Sometimes you accidentally choose the wrong product. You don't mean to delete that one. All right. Notice if it's yes, we will do the remove, the save, and we'll repopulate the list box. But if it's no, we're not going to do anything. And there's our exit. Okay. Now this, notice what's in yellow here. This is asking which one of these has been checked. All right. So I believe what we're doing here, it almost looks like we're using the same form for both of these. But if this is checked, we put author in that text box. If this is checked, we put version in that text box. All right. And that's what they're getting into in there. So the type class, what's in there? Name, returns a string that contains the name of a type. Full name, which is the fully qualified name. In other words, the namespace or where it lives, etc. Plus the type name. Base type, which is the class that the type inherits from, and namespace, which we've seen earlier. There is a getType method, which, as it says, it returns a type object that represents the type of an object. How do you use those? Here are some examples. So notice we create a new product. We initialize it. There's our code. There's our description. There's our author. There's our price. When we ask for the type of product, we get book because it is a book. When we ask for the namespace, we get product maintenance. When we ask for the full name, we get product maintenance .book. And we ask for the base type, we just get product. All right. There are different ways that you can test for the type of an object that you're using. Why would you want to do that? Well, I might want to make sure first that it is a book object before I try to add the information, because otherwise what's going to happen if it's really a software object, that instead of it having an author of a certain name, that author's name will become the version. Probably, in fact, for sure, not what you'd want. So here's ways that you can display the product information. All right, you'll notice in this case, this is all the products it looks like. And in this case, it's a book. All right. Now they talk about casting here, and what will typically happen when you use casting, what will typically happen is the software will try implicitly to cast the way that it thinks it should be done, which sometimes will be correct, quite often will be correct, but sometimes may or may not be correct. So here we're creating a new book, and we're saying display product, and we're passing it with a B. There's, a book is a subclass of product, so we can do that. Here, we are saying product equal new book. So it thinks it's a product and not a book, so we have to cast that as type book. Again, we will look at this stuff in much more depth and breadth of coverage as we go on. All right? So it says here, this will throw an exception, and it should, because we say P is a software object. We're trying to cast it as a book object. All right, and again, it gets screwed up, so to speak, because it's looking for a string that's referred to as version, and it's not finding it. All right. Here's the as operator, P as. So there's different ways that you can do this, okay? Now, when you create an abstract product class, that class cannot be instantiated. It is used as a base for other classes. So for instance, let's pretend for just a moment, and I'm just going to break out of this for a second, we're almost done, but let's pretend for a moment that I create a class called employee. All right, and then I've got an hourly employee. I've got, we'll make it 3 types. A commission employee, and I've got a piece worker. Okay, let me make that a little smaller so it all fits together. So I've got these 3 types of employees. All right, why am I telling you this? Well, I could define information that's common to all employees right there. All right, and then I could make this a child of employee, and this a child of employee, and this a child of employee. And then in hourly, I could add things like, for example, hours worked and hourly rate. And then for commission, I could add things like commission rate. And maybe they had a salary as well. So let me do that. Yeah, we'll put it down here. So salary. All right, and for piece worker, I might have pieces made and, I don't know, price per piece. But you'll notice when we look in here, all right, that these 3 classes that we just created right here, these are all children or derived classes of this. Employee, I don't want to make an employee object. It's too generic. I want to make an hourly employee, which is a type of employee, a commission, which is a type of commission, and a piece worker. So for each one of these, when I create these, I'm going to have in here hourly, colon, employee, which means that it's going to be again, that's going to mean that it is basically that it is a child of employee. All right. Now, I don't have to line these up like little soldiers, but it's totally fine to do that. And I'm going to just put that here. And there. That's what I'm trying to show you. And if that still confuses you, then let's look at it. Let's look at one more example. All right. And that is, let's pretend for a second that I've got a class that's called here animal. And I mean, there's a lot of animals, but I'm going to make 3 kinds. I'm going to have a dog, I'm going to have a cat, and I'm going to have a fish. All right. Those are going to be my 3 different types of animals. All right. You wouldn't tell somebody, I just got a new animal. But all animals have certain things in common. So I could define all of those things that were in common between animals in the animal class and make that abstract. Then I could create dog, and underneath dog, I could make things like, I don't know, Cocker Spaniel, German Shepherd, etc. All right, let's move these. Tell you what, let's move this over. We'll move that over. And under cat, I'm not good with cats. I'm not a cat person, but tabby, calico, etc. And then finally under fish, I could have what? I could have, a goldfish. I don't know what other kinds of fish, if these are supposed to, let's just say shark. Okay. But when I did these, again, I would say dog, and dog inherits from animal. I would say cat, and cat inherits from animal. Finally, I would say fish, and fish inherits from animal. So I would make animal an abstract class, and these would be non-abstract classes. All right, that's what I'm trying to get across to you in here. When you create a class and you make it sealed, what you are saying is that class cannot be, for lack of better words, that particular class cannot be used and inherited from. So it cannot be a parent class. It's reached the end of the hierarchy. So what we're saying here in this example is we cannot have a class that is a child of book. All right, that's what the word sealed there means. All right, and they show an example here of how it's used. Again, we will go through this in class. We're going to look at this kind of stuff in class, all right, and this. But I'm going to quickly do this one, all right, in a couple of minutes. But let's see where I am for time. See, I'm at 28 minutes. I'm not sure if I could do this in one lecture or if it should take two. Just to be sure, I'm going to grab this. Let me do a print screen as I always do. And I'm going to bring that in and then bring this in. And again, as you can see, what's new in here is I'm going to have to widen this out a bit to add an M button, an MC button, an MR button, an MS button, and an M plus button. Let's not worry about what those mean right now. But what I am going to do, since a memory calculator is a type of calculator, all right, I'm going to go to where I have my calculator, which is in here and in here. And I'm going to grab this where I did my CH12 programs right there, and there's my calculator. All right, I'm going to grab my CH12 programs. I'm going to copy it out here, and I'm going to immediately change the name from CH12 programs to CH14 programs. All right, and then I'm going to bring that up. There it is. Now it still says CH12 here. That's okay. Don't worry about that. But I'm going to bring it up. This is the same calculator program that we worked with previously. One or more projects were not loaded. That'll be okay, I think. But here's our calculator. And here is the calculator that we want to create. All right. Leave it like that. Change the size. So again, what we have to, whoops, try that again. What we have to add here is we will widen this out. So we'll widen the form out. And we will add these 4 buttons right here. Everything else looks okay the way it is. So I'll be back to do that in the next lecture. And in fact, just so you can see it, I'm going to come in here and I'm going to unlock my controls. I'm going to widen this out, move this over. All right, I'm going to grab, let's see, one more time, I want to take a look at that. 1, 2, 3, 4, 5. So I'm going to grab this button, I'm going to copy it, and I'm going to paste it. Try to paste it. There it is. So there's 1. In fact, we need it up here. 2, 3, 4, and 5. Now that said, we can now take this, move it over. All right, I'm going to take this, line that up. There we go. All right, and let's see, let's see. That button does look like it's the same height as these buttons, so we can make this one a little bigger. All right, so the only thing I really have to do in here, once I move that in there, Control A, and relock up my interface, all right, is I have to add the names for all of these, okay? And so this will become, let's see, what do we have here? This will become BTN-M, BTN-MC, BTN-MR, BTN-MS, and BTN-M+. These last 4 will be red. This one will be black, just the same way that they've got them in the example that we're working with. I'm going to do that, but I'm not going to tape that. And when I come back, I'll be ready to start working on the project. So we will come back to that in just a couple moments.